Hey, Algebra 2, we are studying for the Unit 9 Logarithms test. I'm going to work through some problems on the study guide. So remember, the idea of a log is that you've got a base and then this result here, and the value of a log is the exponent that gets our base to that result. We also have properties of logs that we use. So this first question is asking about using those properties to combine multiple logs into just one. So we have 3 log 4 plus 4 log 2. Remember, when there's no base written, it's base 10, which we'll come back to. So the first thing we need to do is to combine these to one log is to get this number in front back into its position at the end as an exponent. So this one I would write as log of 4 cubed, and this second log I would move the 4 and write it as log of 2 to the 4th. All right, so I've moved those, and then now my log of 4 cubed plus log of 2 to the 4th, because I have 2 logs with the same base being added together, I can combine them into one by multiplying. So I'm going to multiply 4 cubed times 2 to the 4th. So we could write it this way if we didn't want to actually multiply those numbers out because it's pretty large, but we could actually multiply, right? I could do 4 cubed times 2 to the 4th and see what that number is. It's going to be pretty large, 1024. So that would be log base 10 of 1024. Okay, so remember, you're just using those properties to condense them. Okay, on number 2, it says to evaluate each logarithm, which is the greatest, which is the smallest. Okay, so when you're evaluating a log, yes, there are some calculator options. We know change of base. Some of our calculators have the tool for that, but say your calculator stops working or you don't have one with you. Remember that you can evaluate this. We can't do 64 to the 5th without a calculator, but if I bring the 5 back to the front, it's now 5 times whatever value log base 2 of 64 has. So again, go back to that definition of a log. The value of this log is what exponent takes 2 and gets it to 64. So 2 to what power is 64? And you can work your way up. We know that 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, 2 to the 5th is 32, so 2 to the 6th is 64. So log base 2 of 64 has a value of 6, so 5 times 6 would be 30. So when it says evaluate the log, you're looking for what is the numerical value of that. All right, and again, you can use the properties of logs to make them easier to do with mental math, or depending on how what your teacher has told you, you can use the calculator. All right, number 3 here, rewrite the equation into logarithmic form. So again, that's remembering the definition of a log and what parts go where. So we have 3, base 3 to the exponent 6 equals result 729. So when I write that as a log, I do log of base, so the base is 3, so log base 3 of the result, so of 729, equals exponent. The exponent goes over here, and my exponent was 6. So that's how I would rewrite 3 to the 6th power equals 729. It becomes log base 3 of 729 equals 6. All right, moving on to number 4. We have solve for x round to the nearest hundredth. Okay, so notice I have an equation here. I've got 4 to the 3x power equals 52. Sometimes we're able to rewrite a problem like this and write the other number with the same base. However, 52 cannot be written as 4 to a power. It's not 4 squared or 4 cubed or anything. So basically, I just need to get rid of 4 to the 3x. I need this 4 as a base to go away. So we undo exponents with logarithms. So because the base is 4, I'm going to do log base 4 of 4 to the 3x. because the log base 4 of 4 cancels out, and my result of that is just the 3x. Okay, now when I do something to one side of an equation, I must do it to the other, so that means I'm also going to do the log base 4 of 52. Again, because I did log base 4 of 4 over here to cancel out my 4 to the 3x power. So log base 4 of 52, I will just type in my calculator. So remember, you can either do change of base, so that's, you just use the log base 10 button. So you do log of the result, so log of 52 divided by log of the base 4. Or if your calculator has the log base option, usually under math, alpha, math, with that log base there, you could just type in log base 4 of 52. And we get 2.850, so that does come out to 3x equals 2.85. Okay, so that's not the value of x. I still have to solve for x, so 3x equals 2.85. I'm going to divide by 3 on both sides. So 2.850 divided by 3 gives me 0.95. So my final answer here is x equals 0.95. All right. Looking at number 5 here, we have, actually let me do B. So we have e to the 2 ln x minus e to the ln x. All right. So remember that when e and ln are next to each other, right, if I have e to the ln of x, that just equals x because the e and the ln cancel out. And similarly, if I do the ln of e to the x, that is also just x because the ln and the e cancel out. So I want to rewrite this so the e and the ln are next to each other. So this last one, we can see it's already ready to go. That e and ln would cancel out. That's just minus x. I just bring the x down. But on this first one, e to the 2 ln x, the 2 is in between e and ln, so I have to reposition it. So a number in front of a log can be moved to the end and rewritten as an exponent. So now this first one is e to the ln x squared, and the e and the ln cancel out, and I get x squared. So now I have x squared minus x, and I'm actually going to leave my answer there because x squared and x are not like terms. I can't subtract these, so I would just leave it as x squared minus x. All right, so that gets you through number 5. You can check the next video for 6 through 10.